Hello students, welcome to SmartKidz tutorials. Today we will be learning about is matter around us pure? Chapter from class 9. The chapter is actually a question which says is matter around us pure? So does it mean that we also have impure matter? No. We have something what we call as a pure substance, and we have called something called mixtures. Okay, so when this question is asking us is matter or not pure, what is trying to ask us, which we have to address in this chapter, is matter composed of a single type of particle or a single type of material? The answer is no. In this chapter we will learn that matter is composed of single type of particles, as well as a mixture of them, many such pure substances coming together to form a mixture. Okay, so let's begin with this chapter. We have learnt in the previous chapter about matter. Okay, so we take a step forward from there and learn more about matter, different types of matters, and how we can separate matters in a mixture. Okay, so when we speak about matter, we have addressed, I said in the previous chapter, what is matter. So matter, as we can see, this is a scene in the family, in the house. Okay, everything that you can see in this scene is composed or comprises matter. That means matter is made up of living as well as non-living things as well. So that includes the parents, the children, which are living, the cats, the pets, I mean the cats, the dog, and the cat, the dog, including the toys, the books, the remote control that you can see, or the bookshelf. All this comprises of matter. So matter, remember, is made up of living as well as non-living things. So the definition goes by anything which occupies space and has mass is called matter. Matter can be divided into two categories. Okay, one is pure substance, which consists of single type of particles which are same in their chemical nature, and then we have the mixtures, which consists of two or more particles. So we now go forward to learning what is a mixture and what are its types. Okay, once we have done that, we will go to what are pure substances. So what are mixtures? The mixture, we have seen in the previous slide, that it consists of more than one kind of pure substances. These can be separated by physical methods, which we'll be learning in this particular chapter. So mixtures are of two types. One is homogeneous mixture and heterogeneous mixture, and we will see what are homogeneous mixtures and what are heterogeneous mixtures. Now, homogeneous mixtures is said to be homogeneous if all the components of that mixture are uniformly mixed and there are no boundaries of separation between them. Example is sugar in water, okay, or maybe salt in water. Now let's analyze this statement or this definition of a homogeneous mixture and understand what it means by homogeneous. Now, homogeneous mixture, the first part says if all the components of the mixture are uniformly mixed. Let's take the example. We can see sugar being put in glass, okay, over here, and stirred. Sugar in water, we'll take that example to understand what is a homogeneous mixture. When we dissolve sugar in water, okay, the sugar that we dissolve in water gets distributed evenly. When I say evenly, it means that once we have dissolved the sugar in the water and we consume it or we drink it, do we find that some part of the water in which the sugar is dissolved is sweeter than the other? No. Throughout the water, or, or the water which we start drinking till the end, the sugar content that we feel on our tongue, okay, that we can taste on our tongue, okay, seems to be the same. Okay, it seems to, it's something like when you have a soft drink or when you have a fruity. Okay, what happens when you drink? Do you find some parts of it taste sweeter than the other part? No, that is because the sugar content in that particular liquid has been uniformly dissolved. No? Or in other words, the sugar particles have distributed themselves evenly or uniformly, as we call it. Secondly, the second part of the statement of a homogeneous mixture says that there are no boundaries of separation between them. Once we dissolve the sugar in the water, can we see sugar separately and water separately? No. There are no such boundaries that are formed. You don't see sugar settling down and water on top of it, or water down or sugar floating on top of it. You don't see. So there are no boundaries between them. So remember, for a mixture to be homogeneous, there are two criteria that need to be fulfilled. First is that the whatever you are dissolving in a particular liquid, that needs to dissolve uniformly. Okay, not in some parts it should dissolve more and some it shouldn't be dissolved. Second part about homogeneous mixture, or the criteria that needs to be fulfilled, is there should be no boundaries. That means you should not be able to see whatever you have whatever you have dissolved into that liquid form a separate layer. No two layers should be formed. It should be uniformly dissolved within that particular liquid. So that is about a homogeneous mixture. So here you have given example of sugar in water. You can also have salt in water, or we can have sugar in tea that we prepare. Coming to heterogeneous mixtures. Now, heterogeneous mixtures is the opposite of homogeneous mixtures. In that, it is said to be heterogeneous if all the components of the mixture are not uniformly mixed, and there are visible boundaries of separation between them. Example is water and sand. If you have a look at the video below, the short video, uh, what you see is that the sand is at the bottom, okay, and the liquid, or which is water, is on top. So this is actually a solution of salt and water and sand, but you can't see a boundary or a layer formed by salt. Rather, you see a layer formed by the sand, which is settled down at the bottom. So there's a clear boundary between the sand and the water. Next thing, sand has not dissolved in water. That is why it has, all of it has settled down at the bottom. So heterogeneous mixtures are those where whatever you dissolve in water or in a liquid does not dissolve completely. Okay, does not dissolve at all. And the other thing is there are visible boundaries of separation between them. Example over here is water and sand that is formed. Have a look. Okay, which we can even separate out. So if we, here it is seen, we are filtering it. Okay, where we easily take a strainer, and the salt water is easily passing through. That means the salt is not remaining behind. It is because it is completely dissolved in that water. But the layer of sand which had formed a separate boundary got filtered, as in it got collected in the strainer. What is a solution and what are its properties? Now, a solution is said to be a homogeneous mixture of two or more substances. So as I told you, we have just discussed now that homogeneous mixtures are made up of two components which dissolve very well with each other, or mix very well with each other, so much so that you can't distinguish or differentiate between the two. No two layers are formed. The solution is made up of a homogeneous mixture composed of two or more such substances. Example is your lemonade, which we or soda water, or nimbu soda. Okay, and there are many more things: salt and in water, sugar in water. These are all solutions. Solution has got two components. First is a solvent, and the other one is a solute. What is a solvent? Now, let's take an example to understand what is a solvent. We have sugar in water, right? Sugar solution. Now, the water in which the sugar is dissolved is referred to as a solvent. Okay, and the sugar which gets dissolved or which is dissolved in the solvent, or in this case, in our example, it is water, that is called as a solute. So sugar is the solute and water is the solvent. So what are the different types of solutions? There's a true solution, then there is a suspension, and there are colloids. Three different types of solutions that we need to learn in this chapter: true solution, suspension, and colloids. What are the properties of a solution? First of all, very important part, for any two mixtures to be called as a solution, it should make a homogeneous mixture. Okay, that means there should be no boundaries and uniform distribution should be there of the solute within the solvent. Next, the particles of a solution are smaller than 1 nanometer or 10 raised to minus 9 meters in diameter. So that means we cannot see it with our naked eyes. Because they are so small, they are unable to scatter a beam of light passing through a solution. Okay, so what do you mean by scattering of light? See, when a beam of light usually comes into the room, okay, most of the time we don't see the path in of that light, but sometimes we are able to see a strong ray of light that enters through our window, and we can see few particles that are randomly moving around within that ray of light. You may have observed it probably coming through a small window creak, or coming through some roof if you have a tiled roof. Okay, or even if you go in a forest area, sometimes the rays of light, okay, pass through the dense vegetation, and you can see as it passes through that there are many particles that are moving within that. Now these particles are large enough, okay, to scatter the light. Okay, how when the particle is too small, they are unable to scatter light. Okay, that means light travels in a straight line. When the particles are big enough, these particles are able to deviate the light. That means move the path away from their straight path. And when that happens, light falls in a broader area. And in that doing so, we are able to see the pathway of light. This particular phenomenon is called as a Tyndall effect. Okay, so the path of the light is not visible in a solution because the particles of a solution are too small to scatter a beam of light passing through it. Another important part, which is actually part of the or criteria of the homogeneous mixture, is that solute particles cannot be separated from the mixture. We have seen this in the previous slide, where we had a salt solution in which sand was also mixed. The sand got filtered onto a strainer, but the salt solution passed through. That means the salt did not get filtered, or we could not strain the salt in this case. Now, when we dissolve sugar in the solvent, that is in the water, and let's say we keep it there standing for a long while, do you will you be able to see the sugar settle down at the bottom after a long period of time? You know, many times in the morning, especially, our mommy wakes us up and makes tea for us, and she keeps telling, drink the tea, drink the tea. The tea becomes cold, it's there, and after long time, then we go to drink the tea. But when we go to drink the tea, do you feel that the sugar has settled down at the bottom? No, it does not settle down at the bottom. The sugar does not settle down at the bottom, and we can still have our sweet tea. Same goes with a salt solution or with a sugar solution. Okay, the sugar and the water mixture is very stable. Okay, as a result of which, even after keeping it waiting over there for a very long time, the sugar does not settle at the bottom or does not separate out from the mixture. Coming to the concentration of a solution. When we speak about a concentration of a solution, we speak about how much of the solute is dissolved in the solvent. Okay, what is the content of the solute for a given quantity of a solvent. Let's say if we take sugar and water, where sugar is our solute and water is our solvent, what we look when it comes to calculating the concentration of a solution is what we check how much of sugar has been dissolved in a given quantity of water. That comprises the concentration of our solution. So solution, depending on how much sugar has been dissolved in a particular solvent, can be classified as being a saturated solution or an unsaturated solution. Let us first discuss what is an unsaturated solution. We usually have unsaturated solutions. I'll explain what it means. When we make tea, okay, we dissolve a certain quantity of sugar in the tea. Now, when we dissolve that much, that is as per our taste, as to how sweet we want it. And usually we don't want it too sweet, so that it becomes like a syrup. We just want it to be enough for the tea to taste good. And so when we dissolve the sugar in the tea, the sugar, dissolves completely, and we can't find the sugar anymore in that tea except for the part where we taste it and we know that yes, there is sugar dissolved in it. What if you keep dissolving sugar in the tea? What do you think will happen? Okay. Now, every time you try to dissolve sugar, the same quantity, let's say we take, since we are discussing about tea, we take a teaspoon. Maybe we put 2 teaspoons. Okay, fine, we put 2 teaspoons. Let's say we keep putting many such teaspoons. What you'll observe is that with every teaspoon that you try to dissolve, every teaspoon of sugar that you try to dissolve in your tea, it takes longer time. It becomes a little bit harder or difficult to dissolve the sugar. The sugar will dissolve, but it will take longer time than the first time that you tried dissolving the sugar. Okay? And it keeps getting difficult more and more till you come to a point where when you add the sugar, it no longer dissolves any further. That means the sugar will then settle down to the bottom and you will not be able to, of course, that kind of a tea you won't be able to drink because it will be extremely sweet. The reason why the sugar does not keep dissolving more and more, it doesn't mean that if you keep adding sugar, it will keep dissolving in that given quantity of liquid. No, it won't. It has a capacity, okay, and based on that capacity, it will be able to dissolve the sugar that can go with that mixture. So as long as the sugar dissolves, we call it as an unsaturated solution. But the moment no more sugar when added to the solution, no more sugar is dissolved or can be dissolved, that is the point we call that the sugar has become saturated, or we call it as a saturated solution. So saturated solution is when no more amount of solute can be dissolved in a solution at a particular temperature. Solubility. When we speak about solubility, we refer to the amount of solute that is present in a saturated solution at a given temperature. Okay, so we refer to how much of solute has been possible to be dissolved within a solvent. Okay, at a particular temperature. So at different temperatures the solubility will differ. At higher temperatures the solubility will be much greater. So the concentration of a solution is the amount of solute present within a given amount, or that is a mass or a volume of a solution. Also the amount of solute dissolved in a given mass of or volume of solvent is called as a concentration of the solution. So I've informed you about this, that when we speak about concentration we are referring to the amount of solute that is possible to or that is dissolved within a solvent at a particular temperature. Always remember that with respect to the temperature, at higher temperature, with respect to the temperature, the solubility will vary, the concentration also will vary, because at higher temperatures the solubility will increase. You can dissolve more of the solute, especially when we apply heat, more of the solute can be dissolved. At normal temperature, that is at room temperature, that is the temperature existing within your kitchen or your surroundings in the room, the temperature will be much less and the solubility as a result also will be much less. So in order to calculate the concentration of solution, we take the formula: concentration of a solution is equal to the amount of solute upon the amount of solvent. Amount of solvent, or the amount of solute by the amount of solution. So there are two methods of finding concentration of solution, that is mass by mass percentage of a solution, where we look at mass of solute upon mass of solution into 100. That will give us the mass percentage. And then we have the volume percentage, okay, where it is mass of solute upon the volume of solution into 100. Coming to suspensions. What are suspensions? Let's have a look. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Example is chalk in water or smoke in the air. Now, in case of suspensions, the difference between suspension and solutions are that solutions, we have said, they are homogeneous mixtures and suspensions are heterogeneous mixtures. And we have learned that heterogeneous mixtures means the opposite of homogeneous mixture, in which there are two boundaries formed between the solute and the solvent. Not only that the solute does not uniformly mix or uniformly dissolve within the solvent. The same thing with suspensions, they do not dissolve, okay, in the solvent, but rather remain suspended. Suspended means they are free floating within that particular solvent. Coming to the properties of suspension, first of all, it is a heterogeneous mixture. Same thing we discussed about solutions. The first property over there also was that it is a homogeneous mixture. Now in case of suspension, it is a heterogeneous mixture. Particles of suspension are visible to the naked eye. So obviously these particles are larger than solution particles. Here you go. So the size of the particles, it says, is greater than 100 nanometer. In case of solution, it was 10 nanometers. Here this is 100 nanometers. So obviously they are like 10 times bigger or larger than solution particles, hence visible. Mixture is unstable. We spoke about stable mixture in case of solution, where when we keep a sugar solution standing for a long time, the sugar does not come out of the mixture or form a separate layer. Whereas in case of suspension, we won't see the solute dissolving within the solvent, and the solute, we have said, are suspended within the solvent, so they do not form a stable mixture, as a result of which, if you leave it standing over there, if you do not disturb it, do not stir it, then this solute particles will settle down at the bottom or may float, depending on what is light, whether the particles are lighter than the solvent, or the particles, or the solute particles I mean, are heavier than the solvent. But anyways, it's unstable mixture, that means the solute settle down at the bottom over a period of time. So when we filter it through a filter paper, and this example we have actually seen when we were discussing about heterogeneous mixtures. We had the salt solution which was mixed with sand, and the sand had settled down in the bottom, and when we tried to filter it with the help of a strainer, the salt solution went through or got filtered into the beaker without the salt remaining behind or being filtered on the strainer, but the sand which was had formed a layer in that particular solution, that particular sand got filtered or got strained and collected in the strainer. Being of bigger size, suspension particles are able to scatter a beam of light, so they do exhibit the Tyndall effect. Coming to the colloidal solution, what are colloids? Colloidal solution is made up of heterogeneous mixtures. That means they form separate boundaries and they do not mix well. Okay. The size of the particle lies between true solutions and suspension. So once again, they are quite big particles. They exhibit Tyndall effect, and I've told you what is Tyndall effect. We have discussed about it, and this is the example that I was trying to explain. See the ray of light coming through that window with curtains, and you can see tiny particles here that are visible. Now these particles are responsible for scattering the beam of light, making the pathway of light visible. Because of the light, these particles are not visible. Yeah, you can say that the particles are visible because of this light, but it is these light that make themselves visible by scattering the beam of light, and thereby showing to us, through our naked eyes, we can see the path of light, how it comes through. And this is an experiment that we can see over here. Both these glasses, maybe there is a sugar, both of these are sugar solutions, okay, and there is a torch over here, a laser, and this torch has a beam of light, of course, which is passing through this glass, but we can't see the ray of light passing through this. Then we have the second glass which is clean, and then something is added to that, okay, that means something of a larger particle, that means a colloid, and then it shows this beam of light, okay, that means these particles are able to scatter the beam of light and show us the ray of light. That means it shows that light is passing through this glass and then is passing through this, but because the particles are too small to scatter light, we are unable to see this beam of light over here, but we can see it over here. Coming to the properties of colloidal solution, once again, particles of colloidal solution can't be seen by the naked eyes individually. So colloids are a heterogeneous mixture, and the solute and solvent can be separated by a filter paper. Size of the particles is smaller than suspensions but greater than solutions of 1 nanometer to 100 nanometer. It is a stable mixture, that means particles do not settle down at the bottom over a period of time and do not settle down when left undisturbed, which means colloids are stable. That is what it means. So this is the movement of colloids. They hit against each other and move, and they are on constant motion over here. Okay. And these are some classification based on the physical state of dispersed phase and dispersion medium, and 8 types of colloids are possible over here, which is there even in your textbook. You can go through them and some are very common one that you find in your day-to-day life, like your milk, hair cream, cheese, butter, jellies, then your fog, mist, cloud during the winters that you can see. Apart from that, the whipped cream that you use for making cakes and so forth. Then your soap, leather, froth. And, apart from that, you have also colored glasses and gemstones. There are different types, and then you have something called as dispersed phase and dispersion medium. Now, dispersed phase actually is the solute, and dispersion medium is actually the solvent. But in case of colloids, they are known as dispersed phase because they are dispersed, as in they are moving apart from each, or they are scattered around in that mixture. So that is why it is called dispersed phase, and this is called, the solvent is called as the dispersion medium, in which the solute gets dispersed. That is why it is called dispersion medium, and dispersed phase is the solute which is getting dispersed. Now sometimes it is a solid, sometimes it is a liquid, sometimes it is a gas. Okay, when the solid is when the dispersed phase is solid and the dispersion medium is also solid, we get a something called as solid sol. When there is a solid and a liquid in the dispersion medium, we get a different type of colloid known as sol. Then when dispersed phase is solid and the dispersion medium is a gas, we get an aerosol, something that is also used in your deodorants, perfume. Then we have liquids. If our dispersed phase is liquid and our dispersion medium is solid, then we get a gel that we also put on our hair, or for various purposes that we use, sometimes even in our toothpaste. When the dispersed phase is a liquid and the dispersion medium is also liquid, we get an emulsion, like for example milk, hair, cream. When the dispersed phase is liquid and the dispersion medium is a gas, we get once again an aerosol, similar to one over here where it is solid and gas. This is liquid and gas, we get an aerosol like fog, mist. These are the type actually that comes under deodorant rather than this one, because when we have the deodorant, if we shake, we can hear the liquid in that, yeah, but when we press the button to release the spray, it comes out as a gas. So when it is in the cylinder, it is in the dispersed phase, but when we release the pressure, it comes out into as the dispersion medium, that is in the form of a gas. Then when the dispersed phase is a gas and the dispersion medium is solid, we get solid sol. That is different from solid, that is different from the sol, where the dispersed phase is solid and the dispersion medium is liquid. And lastly, we have where the dispersed phase is a gas and the dispersion medium is liquid, and in that case we get foam. The foam we get even for shaving foams, okay, and then for even some party foams we get, and we get whipped cream, so forth. There are different types of foams available, okay. So in total there are 8 types of colloidal systems possible, basically different combinations of the dispersed phase and the dispersion medium. First we begin with solid, solid with solid, then solid with liquid, then solid with gas. Then we're starting with liquids, liquid with solid, liquid with liquid, and liquid with gas. And finally we have gas with solid and gas with liquid. So there are 8 different types of colloidal systems possible, where the dispersed phase is different and the dispersion medium is different. So over here we end this video, wherein we spoke about the different types of heterogeneous and homogeneous solutions. We spoke about solution, we spoke about a suspension, we also spoke about colloids, and we touched upon the Tyndall effect, how we notice it in our day-to-day lives as well. We even saw it over here. So we are now at a position to address whether is matter pure or not. Yes, matter is not pure, okay. It is made up of mixtures as well as pure substances. So we, just because it is not pure, we don't say it is impure. It just means that it is pure, and that is there is some mixture as well, that pure substances when get together form mixtures, okay. So I hope this lecture has been useful for you to understand various concepts. For this is the part 1, and I hope you keep watching for the next 2 parts in which we will be able to cover this entire chapter on Is Matter Around Us Pure. Thank you for watching. Subscribe to the channel, and if you like the video, please hit the like button. Share it with your friends and classmates as well. Thank you for watching.